Solve each radical equation. Check the answer or answers in the original problem. Alright, we have the equation, the square root of x squared minus 3x minus 14 is equal to 2. Alright, so we have this radical, and it is isolated, so I'll start by squaring both sides. The square root of x squared minus 3x minus 14 squared is just x squared minus 3x minus 14. And that's equal to then, well, 2 squared is 4. So now I look at this equation and say, hey, that is quadratic. So let me get one side equal to 0. I'll subtract 4 from both sides. And so I now have x squared minus 3x minus 18 is equal to 0. And I'll use factoring. X squared minus 3x minus 18 factors as x plus 3 by x minus 6. So then x plus 3 is 0, or x minus 6 is 0, or both. And so we'll solve each of those, subtracting 3 from both sides on the first equation, adding 6 to both sides on the second equation, gives x is negative 3, x is 6. So we have two possible solutions that we need to check. Let's check x equals negative 3. Is the square root of negative 3 squared minus 3 by negative 3 minus 14 equal to 2. So that's the square root of, let's see, that would be 9 plus 9 minus 14. And so that's 18 minus 14, that's 4. The square root of 4 is 2. That checks out. Let's check x equals 6. The square root of 6 squared minus 3 by 6 minus 14. Is this equal to 2? So that's the square root of 36 minus 18 minus 14. 36 minus 18 is 18, and 18 minus 14 is 4, so I have the square root of 4, which is 2, and that checks out as well. And I'm confident in both solutions of the equation. Exercise B. We have the square root of x plus 24 is equal to the square root of x plus 2. Alright, so in this expression we have two radical terms, radical quantities. So there's no, and we have this plus 2 here hanging around. So if we can square both sides of the equation, but we have to be very careful here. So I'm going to do that. Let's square both sides. Now the left-hand side's easy. The square root of x plus 24 squared is just x plus 24. But now on the right-hand side, we have the square root of x plus 2, and that's being squared. Alright, so we've seen this before. I'm going to rewrite this as the square root of x plus 2 times the square root of x plus 2, and multiply it out. So that's the square root of x times the square root of x plus the square root of x times 2 plus 2 times the square root of x plus 2 times 2, right, using the FOIL idea. So now x plus 24 is equal to, well, the square root of x times the square root of x is x. Then I have a 2 square root of x and another 2 square root of x. So that's plus 4 times the square root of x. And 2 times 2 is 4. So now I look at this expression, this equation, and I see, well, there's still a radical. There's still that square root of x. So now I sort of have to repeat the process. I'm going to isolate that radical and square both sides. So to isolate the radical, I'm going to subtract x from both sides, and I'm going to subtract 4 from both sides. So let's see, that would give me then that 20 is equal to 4 times the square root of x. Notice on the left-hand side that x minus x is 0. Okay. I still have a little bit of work to do to isolate the radical. I'll divide through by 4. And that yields that 5 is equal to the square root of x. And now I can square both sides again, which yields that x is 25. All right, let's check our work. Is the square root of 25 plus 24 equal to the square root of 25 add 2? Left-hand side, 25 plus 24 is 49, and the square root of 49 is 7. Right-hand side, the square root of 25 is 5, and 5 plus 2 is 7. That checks out, and I'm confident in the solution.